Welcome to the instructional setup video for the IBM HElayers software development kit. In this video, we'll walk you through how to download, set up, and run the HElayers SDK. To get started, you'll need a running Docker engine on your system running version 19 or higher, and a working internet connection with the ability to pull the latest HElayers instance from Docker Hub. Ideally, the system that you're running it on will have at least 32 gigabytes of memory available for the best results. Note that the HElayers SDK has been tested on S390X and x86 architectures and has runtimes for Linux on IBM Z, Z15 and LinuxONE III, and later, ZOS container extensions, Windows 10 subsystem for Linux, and Mac OS. For this demonstration, we will be using the Python version of the SDK that runs in a Jupyter notebook on an IBM Z15 machine, but the steps in this video will be very similar to the other architectures and runtimes. Let's get started. Step 1. Connect and download the image. The first thing we need to do is open a terminal and connect to your IBM Z machine. Once you have an established connection, pull the latest image to your local Docker repo using the docker pull command. Type into your terminal the command docker pull, then the name of our image. In Docker Hub, it lives in the IBM organization, so it would be IBM com / then the name of the repo, HElayers-pylab-S390X, followed by a colon, and the word latest. Everything to the right of the colon is the tag, which is how we are versioning the images. In this case, we're using the tag latest, which will always give you the newest version of the image. When you're done typing that out, go ahead and hit enter, and it will download the whole image to your local Docker repository. This will take a few seconds. Once it's done downloading, you can check that it exists on your local system by typing the command docker images and the image name IBM com / HElayers-pylab-S390X should be listed in the repository. Step 2. Run the image. Next, we need to run the image in a container and map the port internally to something external so you can view it via your web browser. The command for that is docker run-p for port that we map to 8888:8888. Then we add -d option, so it continues to run in the background, and then we give it a name with the --name option. We call it HElayers-pylab-S390X in this example, but you can name it whatever you want. And finally, it needs to know which image to run, IBM com / HElayers-pylab-S390X : latest. After finishing that, hit enter, and it should return the container ID that the image is being run in. Step 3. Getting started. After it's running, we switch to a web browser and navigate to the URL of the system that you are hosting it on, running on port 8888, followed by /lab ?token equals demo-experience-with-fhe-an-python. Hit enter, and it will open the Jupyter Notebook table of contents in your web browser. On the left-hand side, you can see a list of tutorials and demos to choose from. Double-click the 00 Getting Started notebook to open it. This is the landing page of the HElayers SDK and a starting point for learning about FHE, how to use the HElayers SDK, and where to go next. Step 4. FHE Basics. The first tutorial to open is titled 01 FHE Basics. Double-click on the notebook to open it, and then, as a good practice, click the button with 2 arrows in the top menu to restart the kernel and rerun the whole notebook. This tutorial will run through the basics of how to use the SDK. This will show you how to create a context to work with encrypted data, as well as how to encrypt, decrypt, add, multiply, and rotate vectors in an FHE environment. Step 5. neural network demo. The final tutorial we will talk about in this video is the neural network credit card fraud demo. Double-click on 02 neural network fraud detection to open it, and just like before, click the button with 2 arrows in the top menu to restart the kernel and rerun the whole notebook. This example demonstrates a use case in the finance domain, as well as demonstrating encrypted machine learning. More specifically, the credit card fraud example demonstrates the process of a neural network inference over a fully homomorphic encrypted dataset and model. The neural network and dataset determine fraudulent activities based on anonymized transactions. For the purposes of this demo, the network we used was trained using a realistic dataset implemented by the Kaggle community, and the demonstration is split into a privileged client that has a private key to access the unencrypted data and models, and an unprivileged server that performs homomorphic computation in a completely encrypted fashion. Stay up to date with the latest FHE news from the IBM team by joining our Slack workspace, phekit.slack.com, or you can reach out to us directly via email at phestart@us.ibm.com. Thank you.